David Smith here with another Flip Classroom math lesson. 3 tips before we start. Remember that you can adjust the playback speed if that helps you work through the video. You can also pause the video at any point to take notes or jot down questions. Lastly, you can turn on the captions so you can read my words go by on the screen. Today's topic, trigonometry and right triangles. And we're going to spend a little bit of time right now orienting you to how to label the sides in a right triangle, because this is a little bit confusing. Eventually you'll have it mastered so you don't need to think about it, but in the beginning it's easy to get things swapped around. Okay, so I've drawn up this diagram. Here's our right triangle, 90-degree angle right there. Here's a new thing. I've indicated that this angle here is called theta. That's the Greek letter theta. Okay, it's just a Greek letter. They use it in their alphabet. We tend to use theta to indicate angles in triangles when we're doing trigonometry. Okay, so I have this right triangle here. Here is my right angle. Across from my right angle is the hypotenuse. You already know this term from the Pythagorean theorem. That's the hypotenuse. The way you can tell, it's across from the 90-degree angle. So if you're here at the 90-degree angle and you look across the triangle, you've got the hypotenuse directly across from you. These two sides are not across from the 90-degree angles. They touch it. Okay? All right. So now we need to talk about these other two sides. And how we talk about them depends on where theta is. And this is the key thing. The way I like to teach this the first time around is say, put yourself inside this right triangle. You're standing right there where theta is, and you look out. You have one side over here that's clear across the right triangle. That's called the opposite. It's opposite of theta. So this side with theta here, this would be the opposite side. And indeed, I've labeled it opposite side, and it's across from theta. Okay? Now the other side is the adjacent side. And the way to think of the adjacent side is it's next to or touches theta. So again, we're standing here in theta, looking out into our triangle. We have this opposite side that's all the way across, and we have an adjacent side which touches theta. It's next to. Okay? So what's tricky is that the opposite and the adjacent will switch depending on whether theta is here, as we did it in this example, or theta is up here, because there's 2 possible angles for theta. You'll never see the 90-degree angle listed as theta, but one of the other 2 can be theta. So if theta was here, then this would be opposite and this would be adjacent. Okay? So let's test that. I've marked up a triangle over here, switched it around a little bit, put my theta up here at the top. What I want you to do is pause the video and see if you can use the letters like AB for that side, BC for that side, and AC for that side. See if you can indicate the correct letters for hypotenuse, adjacent, and opposite. And remember, we're using theta up here. So pause the video, see if you can get that. Okay, let's start with the hypotenuse because that one does not switch. It's always opposite of the 90-degree angle. So that would be this side here, that's AB. Okay, now for adjacent. Adjacent is the side that touches theta, or the angle that we're interested in. So here's theta, we're looking out into the triangle, and BC is the one that's next to or adjacent to theta. So that's BC. And the opposite side is opposite of theta. So again, if I'm in the triangle right at theta looking out, AC is completely opposite from theta, does not touch theta. Here's one for you. What do you call a gentleman who spent all summer at the beach? He's a tangent. That's a trigonometry joke. We're going to get to tangent right here. Okay? So let's take a look. We've looked at our triangle. We've figured out how to tell which sides are which. Now what we need to do is look at the actual trigonometric ratios, and I've got them all right there. The first ratio, it's called sine. S-I-N-E is how you spell it out, but we use the abbreviation sin, but you still read that. You call that sine. Now the definition is sine of theta is the opposite side over the hypotenuse. These are side lengths. So if the opposite is 6 and the hypotenuse is 4, then sine theta is 6 over 4. Okay? Theta would be the angle that we're using. That's sine. Cosine, which is abbreviated COS, cos, but we say cosine, is defined as adjacent over hypotenuse. So cosine theta equals the adjacent side over the hypotenuse. Okay? Third one. Tangent, which we abbreviate tan, but we still say tangent. Tangent of theta is the opposite over the adjacent side. So these first two have hypotenuse underneath, but the last one doesn't have the hypotenuse at all. Okay? So one trick to memorize these three things: sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, is SOHCAHTOA. SOHCAHTOA. SOHCAHTOA helps you remember like this. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so you're probably going, whoa, you're defining all these ratios, but how does this, I don't get it. How does it relate to geometry? Let's take a look. So I've put a little right triangle up here, triangle PQR, with a right angle at P, and theta is R. Okay, so what we're going to do here is we're going to say what each of these ratios are using our letters to indicate which sides. So follow along closely. Sine theta. If you remember from here or from sine is opposite over hypotenuse. So theta is right here. The opposite side is this one, PQ. And my hypotenuse is QR. So sine of theta is just this ratio, the length of PQ over the length of QR. Okay? Try cosine. Adjacent over hypotenuse. See if you can write the correct letters for cosine. Okay, let's see how you did. Cosine is adjacent over hypotenuse. So again, from theta, adjacent is PR. That's the side that touches or is next to theta. So that's PR. And then hypotenuse is the same as before. That's QR. So that's cosine. How about tangent? Go ahead and pause the video and try that. Okay, let's see how you did. Tangent, TOA. Tangent is opposite over adjacent. So again, from theta, the opposite is the PQ, and then the adjacent is the PR. Okay? So that's how those ratios get put together. So let's do some problems. Here's a standard 3, 4, 5 right triangle, right angle there, theta up here in the top. Okay? So let's just write down what these ratios are. Sine of theta. Remember, your SOHCAHTOA. This is your roadmap to how to put together these ratios. So sine of theta, here's my theta, is opposite, which is this one. Remember, the opposite side does not touch the theta angle. So it's opposite over hypotenuse, which is across from the right angle. So sine theta is 4/5, which is going to be 0.8 if you put that in on your calculator. Okay? Cosine theta. So cosine is adjacent over hypotenuse. So cosine would be 3/5. Which is going to be 0.6 repeating. Finally, tangent of theta is opposite over adjacent, which would be 4/3, which if you put that in the calculator, it's 1.3 repeating. Okay? So that's some basic type problems that you could get where you're given a triangle with some side lengths on there and you're just asked to come up with the ratios. Okay? You should be comfortable with the fractions and with the decimals. Okay, here's one for you to try. I've drawn another right triangle. I've flipped it, picked a different angle for theta, but same idea. So what I want you to do is write the fractions, turn them into decimals for sine, cosine, and tangent. And remember, your SOHCAHTOA. SOHCAHTOA. Okay, let's take a look at that first one. Sine of theta. So here's my theta. It's opposite over hypotenuse. Sine is opposite over hypotenuse. So the opposite side from theta is looking out through the triangle, the side that does not touch theta and is not the hypotenuse. So sine of theta is going to be opposite, which is 6.5, over hypotenuse, which is 11.3. And that gives us 0.58. So that's the sine of theta. Okay? Let's do cosine. Try that one. Okay, cosine is CA. Cosine equals adjacent over hypotenuse. So again, from this angle, now my adjacent is this side because it touches the angle. So that's 9.2, again, over hypotenuse, just like sine was. So 9.2 over 11.3, which is going to give us 0.81. Lastly, try tangent. Okay, tangent is TOA. Tangent is opposite over adjacent. So tangent, here's my theta. It's going to be opposite, 6.5, over adjacent, which is 9.2. And that one gives us 0.71. Now that you've watched the video, take a minute to jot down notes or questions that you might have for our next class. You can also re-watch portions of the video that didn't sink in the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.